Today we are starting on a really important part of trigonometry, and I want to start by looking at something we did earlier, which was talking about how we're introducing a circle into the picture. So now instead of just looking at a triangle on an x and y axis, we're looking at a triangle whose hypotenuse is the radius of a circle, and as we travel around the circle, the hypotenuse, which is the radius of the circle, stays the same, but the opposite and adjacent sides change. We're going to add one other little caveat to that. We're going to now define specifically the length of the hypotenuse. So if we go back and look at our notes here, we're going to define this circle now to be a unit circle. In a unit circle, the radius equals 1. So if the radius equals 1, and the hypotenuse equals the radius, then the hypotenuse equals 1. So we're looking over here, we're saying that the distance from here to here is 1. Okay, the radius of the circle is 1. Going out from, this is the center, so this is just showing quadrant 1 right here. This is showing quadrant 1. Now, you won't be able to do this on your notes, but of course, being way cooler than you, I can do stuff like this. I can move my little triangle here, and I can assert my right triangle, my 30, 60, 90 right triangle into this little slot right here. Okay, it fits so nicely. Okay, and I just got through telling you here that the radius, or the radius of the circle is 1, so that means the hypotenuse of this triangle is 1. Now you might be thinking, no, we've been doing this, and the hypotenuse of a 30, 60, 90 triangle is 2. There's the rub. We have to figure out what to do with this. So I'm going to take it back over here to where it is on your notes, and we're going to label it the way we've always labeled it. So here we have opposite the 30 degrees is 1, and this would be our 60-degree angle. So the other leg would be the square root of 3, put our little right triangle symbol in, and the hypotenuse is 2. But I want the hypotenuse to be 1. So what do I do to make 2 into 1? Well, I divide it by 2. So if I divide the hypotenuse by 2, then it equals 1. But if I divide the hypotenuse by 2, in order to keep the angles the same, I have to also divide both of the legs by 2, because that means the ratio of the sides will still be the same. It's a similar triangle, and the angles will stay the same. So if I make the hypotenuse equal 1, then the opposite side becomes 1/2, which I'm going to also write in decimal form as 0.5, and the adjacent side becomes the square root of 3 divided by 2, which should look familiar because we've seen trig values that look like that. If we take the square root of 3 divided by 2, that's about 0.866, which I will abbreviate as sometimes as 0.86, sometimes as 0.87, but anyway, that's the number, 0.866, and it goes on. So now when I want to draw this triangle in here and label it, the hypotenuse is 1. Now if we look at this grid here, each of the marks on the grid represents 0.1. So this is 0.1, 0.2, 0.3, 0.4, 0.5. So the height of this triangle, or the opposite side, the side opposite the angle, is 0.5. And the adjacent side, it should be 0.86. 1, 2, 3, 4, 5, 6, 7, 8. That looks about right. So from here to here is about 0.86. Now, if you were plotting a point, you would start at 0, and you would go over 0.86, or which is also the square root of 3 over 2, and then you'd go up 0.5, which is also 1/2. And so the coordinates of the point where the hypotenuse of the angle intersects the circle at this 30-degree mark, the coordinates of this point are the square root of 3 over 2, the length of the adjacent side, and 1/2 the length of the opposite side. Now going back to our original triangle, if we just think of our little 30, 60, 90 triangle with the sides that we're used to putting on it, the 1, the 2, the square root of 3, if we were to calculate sine of 30, actually let me do cosine first just for purposes of my own. So if I were to do cosine of 30, that would be adjacent over hypotenuse, which is the square root of 3 over 2. And if I were to do sine of 30, it would be opposite over hypotenuse, or 1/2. Now notice that the adjacent side is the cosine value and the opposite side now is the sine value when I have a unit circle. And notice also that the x and y coordinates of this point as it travels around the circle, that is the cosine value and the sine value. So the x coordinate equals the cosine of 30 here. The y coordinate equals the sine of 30. This is the important thing that the unit circle does for us. It allows the coordinates of the point on the unit circle actually equal our cosine and sine values. Let's look at another one. Let's go to 45, 45, 90. So once again, I can, being so cool, slide my right triangle over here and put it in the picture. And notice when I do that, if I want the hypotenuse to equal 1, I'm going to have to make some changes, because normally the hypotenuse on a 45, 45, 90 triangle is the square root of 2, but I want it to equal 1. So I'm going to go back over here, and I'm going to make it equal 1. So I take the square root of 2, and I have to divide it by another square root of 2, so it's 1. Now these two sides are normally 1, so I have to divide them each by the square root of 2. And we talked about that that's an okay way to leave it, but you're going to mostly see it written as the square root of 2 over 2. The square root of 2 over 2. Well, the square root of 2 is about 1.4. When you divide that by 2, it's about 0.7. It actually turns out to be 0.71. Now, if we draw our right triangle here on our grid, you can see that 0.71 because I see 1, 2, 3, 4, 5, 6, 7, 7.1. So this is 7.1 from here to here. And then I can see 1, 2, 3, 4, 5, 6, 7. The distance here, the length from here to here is also 0.71. So if the hypotenuse is 1, these two distances are 0.71, which is also the square root of 2 over 2. Square root of 2 over 2. So if I were to go over the square root of 2 and up over in the x direction the square root of 2 over 2 and also up the square root of 2 over 2, that becomes the coordinates of my points. Square root of 2 over 2 for both x and y. Cosine and sine are the same value at 45 degrees. So this is cosine of 45 degrees. That's my x value. Sine of 45 is the y value. Let's do one more special triangle. So my third special triangle here, well actually this is not a different special triangle, it's just tilted a different way. So this is my 30, 60, 90 again, but now I'm looking at the 60-degree angle. Once again, I want the hypotenuse to equal 1, but the hypotenuse does not equal 1, it equals 2. So I have to change that. So if the hypotenuse equals 2, I'm going to do 2 over 2, make that 1. This across from the 60 is square root of 3, so this becomes the square root of 3 divided by 2. And across from the 30-degree angle is 1, so this becomes 1/2. 1/2 is 0.5, the square root of 3 over 2 is 0.866. So labeling my 30, 60, 90 triangle, but now looking at a 60-degree angle here. That's the important angle I'm looking at now. Probably should have put that on the other one. So this is a 45-degree angle that I'm looking at, and this is a 30-degree. Oh, I already wrote theta in there, so I guess I could change that, but I'll just leave it. You guys probably got it. You know, this 45 does not look like a 45. I'm going to make it look a little better. There we go. So now this side is the 0.5 or the 1/2, the adjacent side. The opposite side now is the 0.866 or the square root of 3 over 2, and the coordinates are just reverse order from where they were with 30. So now the x value is 1/2 and the y value is the square root of 3 over 2. So x equals cosine of 60 and y equals sine of 60. I don't think I wrote 45. Yeah, I did up there. Okay, now we talked in a previous video about the 0 and the 90. about how do you figure out cosine and sine for 0 and 90? Well, if x is the cosine and y is the sine, then cosine of 0 equals 1 and sine of 0 equals 0. And that makes sense because here the adjacent side equals the hypotenuse and the opposite side equals 0. When we're up at 90, cosine of 90 equals 0 and sine of 90 equals 1. So the unit circle helps us to find the sine and cosine very easily because they're just the x and y coordinates of the points on the circle. So there is my introduction to quadrant 1 of the unit circle. Then on the next video we're going to look at all 4 quadrants of the unit circle.